Hello and welcome to PA Academy. So in this video, you are going to be learning about the admittance parameter. So the admittance parameter is also called the short circuit parameter. So I'm going to be introducing you to the topic and giving you the formulas and sharing with you how you can solve questions that has to do with Y parameter. Maybe you are asked to calculate the Y parameter, or they call it the admittance parameter or the short circuit parameter. So whatever circuit or whatever question you are given under it at the end of this lecture series on short circuit parameter, I'm very sure that you'll be able to solve just any question. So make sure you watch the video to the end. And if you missed the previous ones on the introduction to two-port network and that of the Z parameter, kindly check the playlist on two-port network and then you'll find a link to all of those videos. So before we get into what Y parameter is all about, if you are new to PA Academy or you are yet to still subscribe to the channel, please can take out time to subscribe. You'll find the subscribe button just below the video on either side of the screen. So please kindly take out 2 seconds now to click on that subscribe button and the little bell icon. Alright, so thank you very much if you have just done that. If you are yet to, please just click on that subscribe button to subscribe to the channel so that you can just get notified of future videos and then you'll be able to see more great content like this. Alright, so thank you very much if you have just done that. So now let's look at Y parameter. So like I said, the Y parameter is the same thing as the admittance parameter or the short circuit parameter. So you need to get yourself familiar with these terms because some questions might not tell you Y parameter. They might just tell you that find the admittance parameter or find the short circuit parameter. So you don't get confused with what exactly they're asking you to do. Exactly. So just like we had it when we were looking at the Z parameter, if you have this, and then let's just illustrate the 2 ports. So this side, the one on the left is the input. If we have it as the input and we have this side to be the output. So this is the current I1 and this is our V1. Then don't forget the polarity, plus minus, this is V2, and then we have this to be our I2. Okay, now for the admittance parameter, the equation is given as our I1 is equals to Y11 V1 plus Y12 V2. Also, I2 is equals to Y21 V1 plus Y22 V2. So this is the equation 1 and this is the equation 2. So this can also be represented in matrix form. Exactly. So in matrix form, so this will be our I1, I2 equals to Y11, Y12 will be Y21, Y22, then we have our V1, V2. Exactly. So some question might tell you to find the admittance matrix. Exactly. So using the knowledge in Z parameter, once you get your Y11, Y12, Y21, and then Y22, you can just rearrange it like this. Also, then the units for the Y, remember the Y is admittance. So the units, the units of admittance, so you can either have it as Siemens, which is S, exactly, or you can just write per ohms, or you can just use the inverted symbol of ohms, so something like this. So you can use any of these three for the unit of that of admittance. Alright, so now let's make reference to the equations 1 and equation 2. Now, just like we did when we were looking at Z parameter, so when our V1 also, so if we take our V1, so when V1 is equals to 0, exactly, so you're going to look at what happens to the equation 1 and equation 2 when V1 is 0. So when V1 is 0, this cancels out because it will be 0 times y11, so it will be out. So with that, our y12, so that means we are going to be having our I, or let me just bring back this equation. So let me just copy it so that we can see it side by side. Okay, so when our v1 is 0, exactly, so let's start with the equation 1. If v1 here is 0, that means we'll be left with I1 is equals to y1 to v2. So with that means our y12 will be equals to I1 over v2. So exactly, so take note of this. So then for equation 2, if our v1 is 0, or when our v1 is 0, so that means we are going to be having I2. So our I2 will be y2 to v2. And once that happens, our y22 will be equals to I2 over v2. So note this. Also, when or if our v2 is equals to 0, exactly, so if we have our v2 to be equals to 0, so from our equation 1, so that means if this is equals to 0, so all these things will be out. So that means our y11 will be equals to I1 over v1. Take note of this. Then over to equation 2, if our v2 is 0, if this is 0, that means our y21 will be equals to I2 over v1. So now, with all that has been said so far with respect to z parameters, y parameter rather, there's another thing you need to take note of so to can help you to solve question under this y parameter. Now, if we have our y parameter in matrix form, so let me write it. If we have it like this, where we have our y11, y12, y21, and y22, is same as having z11, z12, z22, that's the inverse of it, z22 all raised to power minus 1. Are we good? Okay, so what that simply means is the same thing as having z22. Okay, let me write it here because of space. So it's the same thing as having z22 over the determinant of z, and then here we are going to be having minus z12 over the determinant of z, and then here is going to be minus z21 over the determinant of z, and then z11 over determinant of z. So where determinant of z is, okay, let me come down a bit also here. So we have a determinant of z is, so for us to get, just like you do in matrix, so it's just be the multiplication of this minus the multiplication of this. I hope you remember that. So that will be z11 times z22 minus z21 times z12. Are we good? So basically what you are seeing on the screen now is, if a question is asking you to find the y parameter, don't worry, we are still going to look at it, but let me just explain. If a question is asking you to find the y parameter of a particular network or a particular circuit, what you basically do is you go ahead and calculate for the z parameter. Exactly. Just like we did when we are doing a z parameter, follow the same process, the same step. Go ahead and calculate for z11, z12, z21, and z22. Now, after you have gotten your z11, your z22, and then all the z parameters, then you use what we are having here to convert it into y parameter. Exactly. So we are still going to look at example, you're going to understand, but I'm just giving you a summary of what it means. So you're going to use all the z values to get this. So by the time you get your z22, your z22 divided by the magnitude, or the determinant of your z, which is, this is how you are going to get the magnitude of, determinant of z. I don't know, I'm mixing it up. So this is how you're going to get it, the determinant, just the way you do it in matrix. Once you, whatever you get here will be your y11. Exactly. So once you compute this, you get your y12. You compute this, you get your y21. You compute this, you get your y22. I hope you get that. So basically, that is how you are going to use this formula. I want you to take note of this because you are going to use it a lot in solving examples. Exactly. All right. So another thing I also need to share with you, just like I shared with you during the z parameters, is the circuit that they use in representing the y parameters. Exactly, because you might be asked in exams or something. So let me draw it for you. All right, so this is it for the y parameter. So just pay attention to it. So in summary, let me just go over what I talked about in this video before we start to look at examples. So this is the y parameter equation. So take note of this. So I want you to write down all of these equations, that of the z parameter and the y parameter. Look at them closely and try to understand the difference, exactly, so that you don't mix them up. Exactly. So this is it in matrix form. Are we good? And then these are the units for admittance, is Siemens. So you can either write just S, or you write it in ohms per minus 1, or you use just this symbol for it. Okay. So at each point when the voltage is being short circuited, you will have the value of y12, y22, and then y11. All of the admittance value. So here is the conversion of so from the z parameter to y parameter. Exactly. So this is the conversion. Try to understand this also, because you are going to be using it a lot in examples. And then this is the circuit representation of y parameter. So basically that's what I want to cover in this part of this video. So from the next one, we are going to be looking at examples. We are going to be seeing the application of all of these examples and the formula that I've shown you, where I'm going to be showing you how to apply them to solve and answer questions under y parameters. So if you find value in this, please give it a thumbs up. If you have any question or any doubts, let me know in the comment section below. So with this now, let's continue in the next part of this video. Thank you.